I'm Megan, and I'm going to be doing number 6 on test 1, and that is what my group decided was the hardest problem. So, the question says, the weight m of an object on Mars varies directly as its weight e on Earth. A person who weighs 120 pounds on Earth will weigh 48 pounds on Mars. So the first question, it asks us to find a linear function that relates the weight of a person on Mars, using m, to the person's weight on Earth. So this equation, we're going to start with a person on Mars, their weight, and we're going to compare it to a person on Earth. But we're going to use little m, and we're going to solve for little m, which is the mass that compares both of their weights. So after we have this equation, we're going to plug in the numbers that we were given. So for Mars, we were given 48 pounds. And for Earth, we were given 120. After we have this, we solve for little m. So we divide 120 to the other side. And this gives us 2/5. So little m, which is the mass, equals 2/5. And then we plug 2/5 back into the top equation for little m. So we have m equals 2/5 e. And that means a person on Mars will weigh 2/5 of a person on Earth. So there's our top equation. Or we can do it vice versa, meaning a person on Earth will weigh 5/2 of a person on Mars. Either way. So now that we have the first equation, we're going to be doing part B. And the question asks, how much would a person who weighs 190 pounds on Earth be on Mars? So we simply use the top equation, which is m equals 2/5 of e, and we plug in 190 for e, because that's how much a person weighs on Earth. And we're trying to solve for m, which is a person on Mars. So 2/5, 190, and when we multiply that together, we get 76, and your final answer would be a person on Mars would weigh 76 pounds. And that's it.